Let's do this thing. Who knows the answer to this Dom? Does that record? Who knows the answer to this Dom? What is I cubed? Yeah, it's negative I. Here's our little setup for it. If I squared is negative 1, then I cubed is really nothing more than I squared times I, which is nothing more than negative 1 times I, therefore making it very good, negative I. I'll make a little chart over here. I squared equals negative 1. I cubed equals negative I. What's I to the fourth going to be? Very good, positive 1. Because it's just going to be I squared times I squared, which is negative 1 times negative 1, which is positive 1. And what's the square root of negative 1 equal? I. Very good. I is a cyclical little guy. Once you get past 4, he just starts repeating what he does every time. So I to the 5th would be the same as I to the 1st. Essentially, a good way to remember, like if you had I to the 74th, what's he going to equal? Divide by 4. Whatever your remainder is, that's going to be your new exponent. So 74 divided by 4 is, what's that, 18 remainder 2? So that'd be I squared, which is negative 1. We are going to be dealing with imaginary numbers in this chapter. That's what this has to do with anything. Are there any questions on the Dom? Firstly, what we're going to do is just practice some algebra with imaginary numbers. Now, an imaginary number. I never really thought to teach this before, but after teaching some ACT prep recently, there was a question on there, and here were the options. It was like I cubed negative 4 plus I 2I squared I negative I blah blah blah. And the question was, what is a pure imaginary number? Well, these all have i's in them, and a standard form imaginary number means the imaginary portion and the real portion are added or subtracted to each other. So this is standard imaginary. So I didn't really know what it meant at the time by pure imaginary. Does anybody have a theory, looking at these four, which one the pure imaginary would be? Actually, this isn't entirely. There we go. Which of these would be a pure, just have a hunch. Yeah, negative I. Evidently, a pure imaginary number is something that boils down to just some form of I without a real portion being added or subtracted to it. Real portion added or subtracted. 2I squared is just the same as 2 times negative 1, which isn't imaginary at all. And this is a standard form, so this would have been the answer to the pure imaginary. It's nothing more than I. It can have a coefficient, like this one has a negative 1, but it won't have a real portion. Now, you won't need that today, but that was an ACT thing that I saw on an ACT test, so it might prove useful for you there. But for today, what you will need to... Man, I'm going to be cracking all day today. What you will need to know is that standard form of an imaginary number will have a real portion and an imaginary portion. Of course, sometimes the real portion is just 0, but it can have a number being added or subtracted to it. Looking at number 1, if you had to hope for the easiest possible way to work that problem, how do you think number 1 would work? Say a little louder, Jordan. Yeah, exactly, like terms. Exactly. 7 and 1, 2I plus negative 4I, and that's really all there is to adding or subtracting imaginary numbers. Let's look at number 5. Now, what I recommend you do, when you have one of these questions with lots of parentheses, I recommend you get rid of all your parentheses first by distributing through your minus sign. So it'll be 6 plus 5 minus 4I plus 13 plus I. That'll just help you keep it a little clearer if you go ahead and get rid of those parentheses and distribute through your minus sign. So 6 plus 5 plus 13 is 24. Negative 4i plus I is negative 3i. And there's your finished product. Any questions about any problem you see on this screen? I'm pretty sure we've done one pretty much like all of them. Number 7 and 3 are just easier variations of number 5. You just have to distribute your minus sign first. Anybody? Alright, so we're going to skip on ahead. Alrighty, let's see. Find each product and write the result in standard form. As far as you're concerned, i's are going to work like x's when you multiply it through, and then when you're done, anytime you have a squared or a cube, you can simplify it from our DOM. But you're going to treat them like x's right now. So, what would that be? Negative 21i squared plus 15i. We're just treating it like a variable. Distributing. 3i times 7i with a negative. 3 times 7, 21. I is I squared. 3i times 5. 3 times 5 is 15. I times a non-I is I. Now, what's the way I can reduce this? Yeah, I squared is the same as negative 1. So, this is the same as negative 21 times negative 1 plus 15i, which is going to be positive 21 plus 15i. 11 through 19, what do you think the key is there? FOIL, very, very good. As long as you remember to FOIL, those aren't so bad. We'll go ahead and do one. How about, I don't know, 17. Okay. First, outer, inner, last. So that's 25 plus 5i minus 5i, which cancel, minus I squared, which is the same as minus a negative 1. So our whole answer is 26. Imaginary numbers, it occurs to me I didn't give you much introduction to them. They're basically placeholders. You can't take a radical of a negative number. So we use imaginary because somewhere along your problem, if you see a problem with a negative under a radical, it doesn't mean you just have to stop. You're done. There's nowhere you can go. Somewhere algebraically down the line, you may end up multiplying it with another imaginary and turning it into a square, and all of a sudden making it a negative 1, and you're out of the woods. So an I, for our intents and purposes, is basically just a placeholder until we can make the darn thing go away. Sometimes they won't go away, so you just leave the I in there. The hope is they'll go away as often as possible. Questions about any other problems you see on the board? I'd be more than happy to work any of those. Alright. Divide and express the result in standard form. Alright. There are a few rules when you have fractions. Normally I'd say, hey, you're done right here. But you can't have a radical in a denominator. It's called irrational. What? Or an imaginary number. Very good. So, the trick to all of these is to get the imaginary out of the bottom. Let me ask you this. Look at 17, the one we just did here. So I'm glad you suggested that one. You see how when we FOILed those, we were left with no imaginary portion? That's because we FOILed the difference of two perfect... Well, that's not correct entirely. That's because we FOILed the same thing onto itself, but with a different sign, plus and minus. When you do that, that's what's going to happen every time. Because the middle terms will always cancel, and the last one will always become unimaginary. So that's the trick to these. We're going to multiply all four of those, top and bottom, because you can't just multiply something to one without the other, or you would have changed the fraction. We're going to multiply the top and bottom by the, I'm going to call it the additive inverse of the bottom. Actually, we'll call it the multiplicative inverse. But essentially, it's just the same binomial with a different sign in the middle. If it's plus, you make it minus. If it's minus, you make it plus. You can have an imaginary in the numerator, just not the denominator. So, foiling that guy, I'm going to get 9 plus 3i minus 3i minus I squared all over 6 plus 2i. Which gives me 6 plus 2i over, what's this going to be? What's 9 minus I squared? 10. Very good. So that'll be 9 minus negative 1, which will be plus 1. 10. What factors out of the top and the bottom? A 2, yeah. Well. And you're left with 3 plus I over 5 as your finished answer. Now that's an algebraic principle you should have done some in Algebra 2, just maybe not with imaginary numbers. Let's see. Let's say we work 25 and then 27. Those both look a little different than the one we've done. Josh, how am I going to set up 25? What do I need to multiply the top and bottom by? Very good. 4 plus 3i. Now I'm going to give you a second to do your multiplication. Let's see if you get the same thing as me. So get started on that, and then I'll compare my answer with yours. I blow my nose. I don't want to tell people. Yeah. Whenever you're finished, if you want to look up here, see if you got the same thing as me. I may have messed up, so if you didn't, don't just start tearing stuff up. Did anybody get something different than I did that you'd like for us to take a look at, or anything like that? Who got the same thing as me? Oh, that's good. Lots of fun. That makes me feel confident. Does anybody want to discuss any step of this problem? Step 1, 2, 3, or 4? Okay. I can work 27 if you'd like. It's going to set up the exact same way. The only difference is you're going to have to FOIL both the top and the bottom. But what are we going to multiply the top and the bottom by? Holly? Yes. Very good. As long as you have that set up, the rest of it's just multiplication. So it'll be the exact same thing, except you'll have to FOIL on both the top and the bottom. Are there any questions on how that one would work out? Does somebody want to see that? Or are we confident in it? Okay. Alright. Perform the indicated operations and write the result in standard form. Okay, well, the other day we talked about if you have radicals, you cannot add or subtract them. Excuse me. unless they are common. So, what does 29? Well, first off, when you have a negative under a radical, first thing you want to do is pull out the I. So 29 would be I radical 64 minus I radical 25. What's the square root of 64? 8. So that's 8I minus 5I, making the whole thing what? Very good, 3I. Anytime you have a negative under a radical, go ahead and pull out the imaginary. We might work several of these because all of these are a little different. Number 31. First step is what again? Pull out that stinking I. Square root of 16. So that'll be 5I times 4, which is 20I. 3I times what's the square root of 81? So 3I times 9 is 27I, making our grand total 47 imaginary boogers. Questions? Okay. Looks like 33 and 35 are very similar. 35 looks potentially a tad harder because it has, I don't know. When I see more minuses, I tend to think that might be a little harder than anything with pluses. So I'm going to do 35. That'll be negative 3 minus I radical 7 foiled unto itself. And here we go. Foil, positive 9 plus 3I radical 7 plus 3I radical 7 again, and plus I squared times 7. Remember, when you multiply I radical 7 times I radical 7, it's like 2x times 2x would be 4x squared. You do the numbers, you do the radicals. So negative I times negative I is positive I squared. Radical 7 times radical 7 is regular 7. Leaving me with 9 plus 6I radical 7 when you just add your like terms. What's I squared? So that makes this minus 7, making the whole thing 2 plus 6I radical 7. I believe standard form is real and then imaginary, so I don't care when I'm grading your homework, but you should know that maybe for a test, your real portion comes first. Questions on that one? Alright. Let me take these other 4 elsewhere so we'll have more room to work them. Good news is there's only 2 more slides after this one. Yay! Yay! Who could raise your hand and tell me the trick to number 37? Kind of an algebra 2, actually algebra 1 principle. About reducing radicals. Who could tell me the trick to number 37 for reducing that guy? Well, it doesn't really factor, but your head's in the right place. Well, wait, factor what? Yeah, what's under the radical? Into what? Radical 2 times radical 16, yeah. Pull out the I, break it into radical 2 times radical 16, which is I think what you were meaning. Does either of those have a nice and even square root? The 4, right? So negative 8. Let's see, that'll be 4 times I, so 4I radical 2 over 24. What do all of those divide evenly into? 4. So if I divide top and bottom by 4, I get negative 2 plus radical 2 over 6. And that's as far as it goes. I probably shouldn't have left out the dividing by 4 steps, so I'll do it right down here. So 4. Oh, where'd my eye go? There it is. Very good. 39 is going to work almost the exact same way. What perfect square goes into 12? What perfect square number is 4. So you'll break this down into radical 4 and radical 3, and it's going to work the same way. 41. Is there a question on that? 41. We're going to distribute. Now, you can still pull out the I if you'd like. Actually, I take that back. You have to pull out the I. Here's why. Radical 8 times radical negative 8 times negative 3. If you were to just multiply those as is, you'd get positive 24. You know what? I don't want to tell you the wrong thing here. Somebody flip up to the back of your book and tell me what the answer is to number 41 on 2.1. Is it positive or negative 24? I don't want to tell you the wrong thing. It should be, some part of it should be 24 plus or minus like 2 radical 10 or something. 2i radical 10. But is it positive or negative 24? Back of the book, we're in 2.1, number 41. Negative 2 radical 6, you say? So it is negative. Okay. Then you do want to go ahead and pull out your i's first. So I was saying that right. I radical 8 times I radical 3 minus radical 5. So now when you distribute I squared times radical 24. Remember, when you multiply, you can just multiply with none of the radicals. Minus I radical 40. Now we're right back to the same problem we had up here. What perfect square number goes into 24? 4. Yeah. That becomes I squared, which I'll just leave alone for, well, I'll go ahead and make it negative. Negative square root of 4 times the square root of 6 minus I, and then we can do the same thing over here. Radical 4 times radical 10. Which gives us negative 2i radical 6 minus 2i radical 10. No, you cannot divide by 2. I know people are kind of in the factoring mode, but we're not dividing by anything, so you can't just get rid of it. Isn't that what you said the answer was, Joey? Excellent. Good. It's important that you take out your i's in the first step, because if you didn't, you would have gotten positive radical 24, which is what I wanted clarification of. So pull your i's out first. Sounds like we have an Oedipus complex. Anybody in here ever read Oedipus for English? Oedipus read? Good. 2 or 3 of you. So you may have appreciated my Oedipus complex joke. Nobody else probably got it. Okay. 43. My instinct is to have you guys work this on your own. And then my other instinct is that only the people who already know how to do this would do it. So I'm just going to go ahead and do it myself. So here we go. First thing you do, pull out your i's. Now that's what I'm going to think every time. Yes? Touche. There is no I. I don't know where that came from. Good catch. Okay, so that times negative 4I radical 12. I guess you could go ahead and reduce the second one. I think it's easier to just go ahead and multiply. Negative 12I squared times radical 60, and then you reduce. So that's positive 12 times 2, which is 24 radical 15. I do have an answer key, which I will leave up here, and people can come check their answers today. If you're not feeling confident about something, you're more than welcome to do that. Questions on that? Any questions on anything we've done so far? All right, now let's just keep going. Solve each quadratic equation using the quadratic formula. Ooh, I love these. Quadratic formula. Who remembers it? Yes, ma'am. Very nicely put. Excellent. That's exactly correct. A, B, and C are the coefficients in your polynomial, your trinomial. You can only use the quadratic in a trinomial. So, negative B on 45 will be positive 6, because negative negative 6. Plus or minus B squared, which is negative 6 squared, minus 4AC. Now, just a hint, how do you think this is going to tie into the rest of the section? What should you imagine to happen under this radical? You're going to get a negative number. Yeah, that's how it ties in. So, I mean, I guess you might not every time, but I would expect to. 6 plus or minus 36 minus 40 is negative 4 all over 2. Square root of negative 4 is what? 2i. Very good. 6 plus or minus 2i over 2, which reduce to 3 plus or minus I. Quadratic formula. It's a handy dandy little gizmo that we will be using all year. All year. Questions? 49 is going to be just the same as 45 and 47. What's the only thing you have to do first with 49? Yeah, set it equal to 0. Move everything to one side of the equation. So before you work 49, you're going to have to rewrite it as 3x squared minus 8x plus 7 equals 0. But then from there, it's just the same as the others. Questions on that? All right. Last but not least, let's see. 51 and 53 are just the exact same things we've done before, just a little lengthier problems. 51 and 53, we've already done stuff like that and stuff like that. The only difference is when you're done, you have to add and subtract your like terms. Same thing on 53. We've already done these. We've already done these. Just add and subtract your like terms when you're done. 55, again, already done stuff like that. Simplify each one individually, and if you have, well, you know what, we'll work 55. Just in case. 55. That'll be 5 times I square root of 16. What's the square root of 16? 4. So 5 times 4i, which is, well, I'll give you that in a second. And then 3 times, what's this going to be? Oh, maybe we didn't do that. So that's 20i plus 27i. How diggity. We already had a 47i answer. 57 and 59, you're just plugging in for the x values. We're evaluating those functions at an imaginary number. you're just going to plug them in. So I'll set them up. I'm confident you can work through them when you're done. But 57 is 1 plus I squared. You're going to have to FOIL. Minus 2 times 1 plus I plus 2. You're just going to FOIL, distribute, add all your like terms. 59 is going to set up 3i squared plus 19 all over 2 minus 3i. What are we going to have to do to this one before we're done? The big R word. Yeah, we're going to have to rationalize it. You can't have that imaginary in the denominator, but again, going back to, I'll go back to that in a second. Going back to these slides, we've already done that too. You just got to rationalize it by multiplying the top and bottom by. If this question is answered correctly, we can be done for the day. Austin, what are we multiplying the top and the bottom by here? Just 2 plus 3i, but yeah, very good. Yeah, I figured. All right, muchos goodos. Here we go.